Oh, wow.
All right. Sorry if it doesn't look so well as before. I kind of filled in the blanks right away. Oh, thanks. You're so understanding. Today, combinations of functions, composite functions. We'll be looking at some domains. We'll be looking at the domain of functions, combining some functions, forming composite functions, determine those domains and of the composite functions, and then we're going to write some functions of our own. Okay? So, we out here trying to function.
I'm so ready for this.
Are you so ready? Nah. All right. You guys got this though, right? Can I change this slide?
Yeah.
All right, cool. Let's move on. Finding a function's domain. Here's something very formal for you. You don't have to write it down. I think you guys already have the idea of what that is, right? But if a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which every value of f of x is a real number. Excludes from function's domain real numbers that cause division by 0 and real numbers that result in the square root of a negative number. So it's just saying you can't break math by dividing by 0, and of course you can't have imaginaries in there either. Okay? So, ready? So here's our first example. We want to find the domain of this bad boy. Now, for starters, there's two things that can't happen, right? So I'm not taking the square root, so I don't have to worry about those imaginaries. But I do have to worry about the denominator being 0, right? Because I can't make it so that that becomes 0. So I'm going to ask math, hey math, when does x squared minus 49 equal 0? And of course, we can go through the process algebraically and figure that x will be plus or minus 7. So, the denominator will be 0 when the value of x is a positive or a negative 7. Which means, pretty much, hey, I can just about pick anything except for
7 or negative 7.
7 or negative 7. So for your domain, you can say, I don't know, x such that x cannot equal plus minus 7. That'll work. What? There's not coffee yet. I sip on it all day. Coffee is delicioso. Questions on this example?
Do you have a Keurig?
Do I have a what?
A Keurig?
I do. I don't like it.
What do you use?
Why not?
Drip.
Why don't you like it? What did it do to
I don't
you?
feel like it's strong enough, like the pressure is strong enough to make it like
Well, but you can adjust it.
not mine.
Oh.
I don't know. I have to check, but I don't think so.
Mine, like you're talking about like when you say
Strength?
that. Yeah, yeah.
Yeah, you
Mine
make the
has,
strength of the
if you
coffee?
want-
Oh, those are the new Keurigs.
Yeah, yeah.
I bought one of the first ones and I never liked it, so I was like,
You should try the new one.
new one.
Because I use the other one because I don't really need that much, but my parents put it all the way down on the bottom.
I like my drip. I do want to try that French press one though. For that.
Oh, yeah, yeah, yeah.
Can I change the slide?
Yes.
All right, cool beans. Let's talk about composition of functions. Okay. So for some compositions, they're going to ask you to operate on a couple functions. They'll ask you to combine them. That'll look like this f plus g business. They'll ask you to subtract them, which is f minus g. And of course, if there's no symbol between them, that means to multiply them. And of course, it's if f over g, they're asking you to divide the two functions. So these are the different ways they can ask you to do things to create another function. And I think we've kind of been doing some of that, right? With the rational expressions and all that business.
Yeah.
So now we're going to throw in a little bit another parts of that. You guys okay with this slide?
Yes, sir. Yeah.
Just be careful that your denominator does not become 0. That's what that's saying there. You don't want g of x ending up being 0. Okay? All right, let's have you guys try this for a little bit. Combining functions. We've got two functions here. We got f of x and we have g of x. Let me go ahead and highlight those for you because you can't see them very well. So here's g of x. Sorry, that's f of x. And here's g of x. And they want us to create these new functions, f plus g of x. and I have answers up here. Why did I do that? Where's my pen? You can't have it. Gone. Okay, so here's what we want to do. From that, we want to create new functions called f plus g of x, and it really is just adding the two. So if I've got x minus 5, I'm going to add to that x squared minus 1. That should produce for me what I'm looking for. So I've got x squared. That shaking is driving me crazy. Plus x. Negative 5 and negative 1 will make negative 6. Excuse me. And there's our new function. There's our new function. There's f plus g of x. Okay? What's the domain on this thing? So is there any value of x that I can put in there that will make the denominator 0?
No.
No, because there is no denominator. So I'm good there, right?
Yeah.
Is there anything that I can plug in there that's going to give me some imaginary values?
No.
Pi. I don't know what I'm
Green. Or,
I can't.
What's up?
3 and negative.
I can put 2 in there?
2 and negative 3.
Well, the square root of a negative number. Well, there's no square roots in there, is there?
But I don't understand.
What if x is the square root?
Never mind, I retreat.
So
Or
x
it's
can
just
equal
2x plus 3.
to a negative 3? It can equal that?
Yeah, because it's not.
When you factor it, those are the zeros.
Well, in this case, we're looking for domain only, guys. What shape is it? You guys should recognize this. What is it?
Parabola.
It's a parabola.
Yeah.
It's a right side up parabola, right? So what is its domain? Regardless of where it's at, what's the domain?
Negative.
All numbers. Because I'm not taking the square root of anything in there on this specific problem, and I don't have a denominator. So my domain is all real numbers. Some people will get deep. Okay, we're not saying anything about whether it's going to have imaginary roots or zeros. Remember that? Because you can get those, but we're only worried about those two conditions right now. And we're okay with those, right?
Yeah.
Elijah? Questions on this domain? May I change the slide? Composition of functions. Here's some notation that you need to recognize. And it's fog. You guys remember fog, right? No? Right here? That's fog is f of g. They're telling you that they want you to compose a function. It can also be written just like this, where they want you to take the g function and stuff the whole g function into the f function. So those two writing, yeah, think about those Russian nesting dolls. You guys ever seen those?
Yeah.
Like a doll, it's a doll inside of a doll inside of a doll. That's what we're doing. We're doing composition of functions. Okay? A turducken?
Turducken. I want one.
That's what you thought of? Turducken.
Because he said chicken, and I was like,
Oh, okay. Real quick question, guys. Taking a look at this notation, what's my main function? What's my function on the outside, the skeleton? F. Left to right. It's going to be the first one, okay? F, and we're stuffing G into that. Can I change the slide? No, I can't. I'll just have some Java. Terry, you okay there? Amen. I thought you were like, amen. I'm sorry your head hurts. I can change the slide now? If you tell me not to, you gotta tell me when to. Alright, here we go, check it out! Forming composite functions. Here, they want me to create this function, fog, or f of, oh, I still have a highlighter on. I'm trying to find fog, f of g of x. So, I'm going to start with my main function, which is the f function. The f function happens to be 5x plus 6, yeah?
Yeah.
So I need to put something into here. The only place to put it in is going to be in this spot right here. And guess what I'm going to plug in there? The g function, which happens to be 2x squared minus x minus 1. I'm going to take that, transfer it in here, and then I'm going to go ahead and expand that and clean it up and simplify. 5 times 2 is going to give me 10x squared minus 5x minus 6 plus 6. JK, thank you. Minus 5. So I've got 10x squared minus 5x plus 1. This is f of g of x. My writing got big, small, 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 small. Go to the bathroom. Thanks for sharing. We all do it though. Alright, anyways. Questions on this? Composition of functions? Question, since I found fog, would goth be the same thing? We found f of g, would g of f be the same?
No.
No?
No.
Yes.
No.
See, it's the commutative property.
No. Because you have to put it in twice.
I don't know.
So whenever you would do that, you'd be putting the 5x plus 6 into where the x's are in the g of x.
So you're saying it wouldn't simplify it to be the same thing?
Let's find out, man.
Yeah, it would be different, guys.
Sheesh.
F of g is not the same as g of f, so don't get that confused. Anybody want to see g of f?
Yes.
Yes, let's do it. All right, so are we done with fog? Bye, fog.
Clear up that fog.
So there's fog. Let's do goth. For goth, we're taking 2, square that, minus x minus 1. And of course, we'd be plugging in
5x plus 6.
wrong side. 5x plus 6. 5x plus 6. That would give us 2 times. Wow, that's messing with my eyes. 5x squared. What's that, 60? X? I'm expanding 5x plus 6. We're good? Okay, you got me doubting myself. Minus 5x minus 6 minus 1.
Yeah.
I distributed the negative. Right?
Yes.
Alright, so that gives me 50x squared plus a buck 20x plus 72.
Yep.
Yeah?
Oh yeah.
Minus 5x minus 7. Oh my manta. I've got 50x squared plus 115x plus 65. Yay! Here's goth of x. It was not necessary, but it was fun. Yay!
That's the one. I was actually good at these last year. The one thing, blazing transformation.
Okay? Okay? You guys all got quiet. Oh, we're just waiting for next slide? Okay. That's it. I'm just kidding.
I wish.
No, there's not very many more. 3 more slides. Forming composite functions. So here's another one. We want to find fog here. Okay. So we're going to start with 4 over x plus 2. What's going to go in here? 1 over x is correct. So 1 over x. That's going to give me... No, that's not going to give me that. That's going to give me x plus 2x over x. Yeah? No, it should be 1 plus 2x. Why don't you correct me? Thanks. Funny. Yeah? Did I skip a step too many? Alright, let's go back. So there's my numerator, right? my denominator needs to be x for both of these because it's a 1. That this denominator change on the 1 over x. So the numerator won't change. That the denominator change on 1. I got to multiply by x, so I'll do the same thing to the top. That gives me 2x here. So here's where we were at, right? Now that 4 is 4 over 1, and I'm multiplying by the reciprocal. So I got 4x over 1 plus 2x. So here is fog.
Can you divide by 2x?
No, I cannot. Because I don't have a 2x here. This is one number. The denominator is one whole number. And I know what you were thinking there, but that won't work for us. So do we have restrictions on our domain?
Yes.
X cannot be negative 1/2. It can be 0.
Yeah.
X can definitely be 0.
Because
Because what's 2 times 0? 0 plus 1 is 1. So if you can't see it, then here's what you'll ask.
It can be
Hey,
negative 1/2.
when will 1 plus 2x be 0? So I will never be that. When x is negative 1/2, then my denominator would be 0. So I say, hey, you can be any number except for
Negative 1.
negative 1/2. Right? That is the slide. Yeah. Is that what you want? Is that what you want? Just floating. Yeah?
Are you in fifth?
Hmm? Am I what?
It made a fan joke.
Oh,
It was funny.
I didn't hear it.
Parker, why are you laughing? You left. You left us, Parker.
Oh, I see what you're talking about. What do I need here?
Did you know how to cook it?
Oh my gosh, you has it too. Aw.
Yes, queen.
Wow.
I know what you're talking about now. Can we change the slide?
Yes.
Going. Decomposing functions. So we were composing functions. Now we need to decompose functions. So not put them together, but to separate them. And it's not that bad. It's not that bad.
This is our last slide.
Look. Here I have h of x, which was the square root of x squared plus 5. I can break that up into the square root of something. Well, one inside was the x squared plus 5.
But it's not always going to be like that.
But it should be pretty obvious. Hopefully.
Thanks.
Right? So, we okay with decomposition?
Yes, we are.
Don't make it a big deal. Once you make it a big deal, it becomes hard. Don't do that. Okay? Guys, that's all I've got.